a brief intro here for myself. My name is Matthew Seal. I work at Netflix on the Big Data Platform team. In particular, I work on orchestration systems for helping schedule and manage execution of work on behalf of other engineers. So I do a lot of integrations with data engineers and data analysts, as well as system devs that aren't as used to that realm that need to be able to get their data or some analytics about their service or app in a pattern that they haven't used yet that data engineering is more familiar with. So it becomes a kind of a bridge point for a lot of different user groups that all need the same needs. So what's this kind of look like, and what does a data platform team do? I think in this crowd, it'll be a little more well-known, but just as a kind of walkthrough and rehash of how this works for us. You have many different data inputs. These can be events from different click actions or user input data or system metrics or other sources of data. And they all need to be kind of ETL'd. We need to extract that data and transform it into something useful. And this is where the data platform services come in, which is the types of systems I help build. Basically, you want to feed this raw data into some useful state, and then you're going to put it through some transfer. You're going to put it in other systems. You're going to get it to certain users. And then you're going to do some sort of aggregations or machine learning or reporting on it. And the final outcome on the far right is that you want to basically have some business value actions as a result of the data being processed. So the Big Data Platform Services team is really about building the tools so that people trying to get the data from the left to the right can do their job easier. And that's part of what I'm talking about here is kind of using a technology that we're going to dig into in a minute that's helped this process some and making it a little smoother for users, especially users that aren't as familiar with traditional tools. All right, so since we're at a Netflix talk, we have to do some memes or some show references. So one thing, what's data platform do? At the end of the day, we open doors, just not this one. So I'm going to be talking a little bit about open source projects in Jupyter and nteract. Nteract is a group of libraries. It's got a GitHub and nice online documentation that is like an ecosystem of tools around the Jupyter ecosystem, which is a broader group of tools for doing different programming models and data munging. And the kind of ownership model here is these are open source projects. All the thing I'm talking about are open source. But then Netflix is a large contributor into these projects, and we try to be as supportive of the open source as we can. All right. So the thing we're going to actually jump into first is what are Jupyter Notebooks. The tool we're going to talk about later is called Papermill, but if you don't know what Jupyter Notebooks are, it'll be a little hard to talk about. So a notebook is effectively an interface that has a REPL to a REPL that's executing code on your behalf. So it's sort of like the way you have an interface that has broken down pieces of code that you can execute individually and sort of iterate through independently. The interesting thing with notebooks is that it's a little more human-friendly into the sense that it has a little more web integration and a little more integration with visuals built out of the box. It also has the ability to replace particular code snippets over and over again while the state of your execution is being held in the background. So much like a REPL where you can have an open console and you maybe make some programming calls and then you make additional programming calls and keep iterating until you get some solution you like. This is sort of a way of tracking that in a more collected and human-friendly manner. What the breakdown of this actually gives you in completeness is really around the code that you want to have executed, as well as markdown and documentation, and the ability to log the outcome. So one of the really nice things is as your code executes, you can actually see all the outputs, like the std out, the std-er. You can output displays, even objects that you just have allocated. You can render those automatically with standard conversions to text outputs or visual outputs. And so it has a really nice thing of what you're executing and what the outcomes were all bundled together in one place. Where this really shines is for iterative development. So if you don't quite know what your code needs to look like yet, or you don't know what your data shape looks like, it's a really handy tool for being able to kind of explore without having to redo all the computation over and over again from scratch. It's also really handy to share results. Or to integrate with various API calls. So here you can kind of play out how you did something, like integrate a tool or experiment with something or prototype something. You can share it by just giving this notebook file or the notebook link to someone else, and they can reproduce exactly what you ran. And that's really important for later, what we're going to talk about. So break down like what are these pieces. Over here on the right is the nteract version of the UI. There's several different Jupyter UIs. There's like a status and core your standard like file operators at the top. And then you'll have this thing called a code cell. So that block of code right there is called a cell. And that's what your input to the system is. And then your outputs are displayed in between the cells. So you'll see we had 3 cells here. One was a markdown cell that rendered the markdown. One was a code cell. And then the last one had a code cell that called this display call, which rendered a graph for us. And the same thing for anything I print out while I'm executing is going to show up as outputs in between the cells saying this is what I said happened during this cell. OK, so we talked a little bit about what the valuable use cases are, but the wins really come around the shareability, the ease of reading, and the documentation of code. It also has a pretty nice outcome that if you ran this thing, exactly what you did is well documented and associated. So you don't have to search through 5 systems to find the logs and hope they're the right logs for the right action that you took. And the other nice thing is it's multilingual. So while I'm going to be showing Python code mostly here, you can run a REPL of any REPL that supports the protocol. That's what the Jupyter ecosystem kind of helps define is that protocol so you can match the different languages and systems. So how does this work a bit? What we just showed is really a Jupyter UI. In particular, I was showing the nteract, and then you also see the classic UI. And where you have this is a little bit of a simplified view of what's actually happening under the hood. But basically, you have the UI with the user interacting with it. You've loaded some notebook file. It's on some disk or an S3 or Azure. And then you have some Jupyter server that's sitting there hosting this website for you and replaying the requested actions you have down to a Jupyter kernel. A kernel is a name in the notebook space for the REPL wrapper. It's the command that launches the REPL and holds the state for you. Oops. And the one thing to kind of note here with the way this communication works is the Jupyter server and the Jupyter kernel kind of fulfill this protocol of communication of what messages need to go back and forth. And then the client is sort of listening to those messages. So they'll say something like, execute this code. They'll send that over a channel. And then they get back kind of asynchronously all the outcomes until it says, I'm done executing what you requested. And all that kind of gets hidden from you. So as a user, you just need to know, hey, I have some code. I'm executing it. There's some state being held as that code executes. So where this really comes in as a traditional tool is back when notebooks kind of started becoming popularized, probably in the earlier 2000s. It was really a tool for data scientists where they could explore and analyze data from a system or from an external point of contact without having to refetch that data over and over and over again, which was the expensive part of their iteration cycle. So you could fetch the data once, hold on to it, and then try different models, try different explorations, try different queries until you were satisfied with the result. So the good thing with notebooks is they're really good for quick iteration, capture expensive queries. They're very good at recording your outputs, and they're pretty easy to modify. You can take an existing one, touch it slightly. It's kind of a more sophisticated version of just some Python script or some JavaScript you have sitting around that maybe it's difficult for someone to capture what it did and how it works. It's a little bit of improvement on that. But there's some drawbacks, and these drawbacks kind of kept it to a more isolated community and didn't see a lot of production use. It was usually an exploration tool, and then you stopped there and rewrote everything you did in your notebook in some system that your company actually supported. And the bad is the fact that as you're editing your notebook file without some of the extended tools that are becoming popularized now, you lack history of what your edits were. So you don't have version control baked in, because at the time this was made, version control wasn't that popular in all groups. It's a little difficult to test, at least traditionally. The document is mutable, so if you shared it with someone and you're both editing at the same time, bad things happen. Some of those have gotten better or will become much better in the future. And it's a little hard to parameterize. You have to make the notebook and kind of have human readable documentation at the top of when you want to use this, change this value to whatever you need. Right? So it's not very system friendly, it's more human friendly. So one place we came in at Netflix was we had a lot of users using notebooks, and there was a lot of friction around those users wanting to be able to just run this notebook. You can run my Python script, why can't you run my notebook? It's already set up to do what I want. So this is where a lot of investment came into this library called Papermill. So things that we wanted to focus on helping improve for our users, and the kind of philosophy here was rather than forcing our users to go away from a technology that they liked, we wanted to move our tooling closer to support the technology they were already using. So things we wanted to preserve were the results linked to code. That's really nice. Matter of fact, that's probably the best feature of this system. It's been the most useful for everyone all around. It has good visualization, so you can set up a notebook so it's very clear about why decisions were made, especially when you have very complex data decisions. You can graph and plot the things that drive the engine that you're executing against. And it's really easy to share, especially if you make read-only interfaces, which is another technology we invested in around notebooks. But things we wanted to prove was the versioning, like the fact that you have a mutable object makes it really hard to reason about how it's going to behave and how it did behave. And the fact that you couldn't really templatize it. It required human templating. So Papermill is sort of a pun on the idea of churning out notebooks, and so which is exactly what it does. It's an nteract library, and effectively what it does is it actually isolates the input and the output. So Papermill takes some input source. It could be EFS, it can be mounted in S3, it can be anywhere in the ecosystem or in a local file system. You point to one of those schemes and pull that data in, and then you execute Papermill on it, and it'll actually run through, as a client without a UI, it'll run through executing all the cells in order. And then it'll outcome to an outcome location that you specify. So what this does is you can actually specify, hey, I want this to go to run 54, and next time we run 55, and so on and so forth. This means you can kind of keep a record of everything you ran, especially if you have any organization scheme around how you store your kind of batch executions. All right, so we're going to talk a little bit about how this looks like in code, because it's a very simple library to interface with. There isn't actually that much code in the library. If you read it, it's like less than 1,000 lines. But effectively, in Python, if you were to execute this from Python, since it's a Python library, it also has a CLI we'll show in a minute, you can just basically call this papermill.execute notebook, give an input path, give an output path, it'll do exactly what I just described. If you ran this a bunch of times and you parameterize your output, you can see here we use the date of the run. Maybe you run it once a day. You can actually point that to an output path, and then you can read all the runs that ran there. We use this a lot where we'll have job executions that a user has scheduled, and then we will map those into a unique path. So you can actually see all the executions that ever ran for this job definition. And it means you can also recall and restore one of those. Like maybe last Tuesday's run was the right thing to do, and today isn't, and you need to quickly figure out what you did last Tuesday. You can just go load what ran and rerun it or play with it. It has another really nice feature that's introduced. This is the ability to templatize your notebook. So you have the ability here to actually add parameters that get passed and injected into the notebook. So here, let's say we have some notebook that wants to count the number of viewers on devices in certain regions. Now, if you think that's a pretty useful little integration, maybe just do a quick query and make a graph, or do a query and ask another system to join that data. Here, what we're going to be doing is we want to basically say, hey, normally we run this as default to see how many PCs are in the US that are watching the stream. Maybe that's something you're interested in by default. And then in the notebook, you'll have a cell in there that you mark with the region, the devices, and the other defaults you want. And you'll tag that cell with this tag called a parameter. And then whenever Papermill runs, it'll look for that tag and inject code after it. Or if it doesn't find this, it'll just put it at the top of your notebook. So the way the templatizing works in Papermill is really, really simple. It just takes the JSON of the inputs you're giving it and converts that in the code in a cell. So you'll get a new cell in your notebook that has all your parameterization applied. And where this is really nice is you can kind of choose what you override, and it's really straightforward. Like I say region equals foo, you're going to get region equals foo inside your notebook and in whatever language that notebook is in. All right, so Papermill also has usage as a CLI. We actually use it more as a CLI than a Python library. In particular, the CLI version here is just like Papermill, input path, output path, and then you can give it a bunch of parameters in different forms with a few options that collect them. And this can be passed in as JSON, YAML, individual key value pairs, and so on and so forth. And it'll do the same thing. So if we go back to this kind of view of how notebooks execute and how they look when you have a Jupyter server and a user interacting, how does Papermill interact in this picture? Well, namely, Papermill sort of replaces the user and the UI aspect. It acts as another client that talks over the same protocol and the same pattern that the web server would. In this case, all it's doing is instead of iterating on this live document, it reads in the document, whatever touches the original source, sends that over the kernel, propagates it at the kernel to actually execute, gets back all the replies, collects them just like a normal UI would, and then when it's all, every time a cell finishes execution, it's going to save to the output. And what the only really difference here is that much like a user would go in and edit a cell and add in like I want region equals US or I want region equals Canada, here Papermill is doing that on your behalf programmatically. By having those inputs, you can say, hey, I want to run in this region, and then run this notebook for that particular templatization. It also records what the templates are and in the metadata and other things, so it's easy to programmatically ask what you did. All right, so to dig in a bit more on how it actually works, if you look into the details more than just, hey, it takes things in and puts them out, it actually has a plug-and-play framework in here where you can give it a notebook source and register what type of sources, what schemes you can support. It lets you inject the parameters through a variety of means, and these get injected as the cell into your code. And then when it runs and talks to it actually launches a runtime manager that launches the kernel under the hood as a subprocess. So it's actually launching that REPL on your behalf whenever you run based on the definition of how Jupyter defines the spec. So Jupyter sets the whole framework. We follow the framework to launch up your REPL and run it, and then shut it down when it's all done. And then the output can go to the same source sinks as we have sources. So in our example, like at Netflix, when we use this a lot, many times we always set the sink to be S3, and we have like a fixed S3 path. So we always dump it in S3 where we're never going to touch the file again. That means we have a good record of like what happened without having to even introduce version control yet. There is ways to also integrate this in with like version control systems if you wanted to, pretty easily. But in our case, for like getting a very simple story, this was an easy way to get a win. All right, so one of the advantages, like why would I do things in a notebook instead of just writing a script or having my custom tool I already know about? Well, things you can actually do is you can now programmatically iterate over a parameter. Let's say you're doing a machine learning process and you want to try different alpha values for a particular algorithm. Well, you could build a whole ecosystem around running that, or if you already have something where you've been exploring how to apply this alpha in a notebook, one of the advantages here is you can just schedule that notebook and not rewrite your code. So you can fan out on a property and use the same notebook template and run it 4 times, and then you can parameterize for each one and see how each of them did. Another really nice thing about the way Papermill is set up is that not only does it introduce new users, but it's also highly extensible. So by kind of adding in this new paradigm, we also gave it a lot of room for being able to add new use cases that we didn't think about yet. In particular, the way parameterization works, the way inputs and outputs work, and the way even it executes the notebook are all registered in the class as a registry. So anyone who wants to extend the library or use it in a new way, it's very easy for them in a couple lines of code to overwrite. And I'll actually show how you can do that later. But what this actually we have found has opened up is it opened up the use case for using notebooks to a lot more users than has traditionally been used. In particular, now it's not just data scientists iterating and exploring. We're getting a lot more analysts and even a few data engineers who use this for things where they want to see what they're doing as they're working, and then they don't want to risk rewriting that and messing it up. And they want to have familiarity if they want to go back and edit. They remember how this worked and what it looked like. And so we've been having a lot of really good success around using Papermill to help achieve this kind of usage and reduce the friction for some of our users. I think the largest growing group has probably been analysts, where they oftentimes have to write some SQL, they have to kind of get some outcome or report, and when they have to jump between 5 systems, it makes their job harder. We talked about the plug and play. Today, if you just download Papermill as is, it supports a few different cloud targets out of the box. In particular, S3, the various Azure Data Lake and Blob Store, and the Google Cloud Store are all supported right away. Obviously, you need some credentials. We won't plug you into our system and say, right to our S3. Yeah, and so we've talked a little about the plug-and-play architecture, so I'm going to dig a little bit more into what that actually looks like. So since the entire library is component-based, you can overwrite any component, not by having to monkey patch anything, not by having to go overwrite code. If you really had to, and there are some few users that do that for some specialized use cases, you can. But in general, most of the time, you can actually get away by just registering a new execution that you want to do. For example, let's say you have an SFTP server you need to talk to as your source. Who knows why you have that as where your notebooks are living, but it could be. Or someone's trying to share something with you externally, and this is the way they share. So this would actually be all the code you would need to write in order to add that support to Papermill. You need to implement a read function and a write function for the file path and the file contents. And then all to register this new endpoint, all you have to do in your own setup tools is register an entry point to add the SFTP scheme into the Papermill's IO read write registry. And after you do this, then your execution down here, where you do execute notebook and say SFTP / my FTP path, will actually start working using your code right away. You don't actually have to monkey patch anything. This is a relatively new feature, like in the last 4 months. So our system still does the sort of go in and touch more directly. And there what you actually do if you want to have more of a wrapper is we wrap with CLI, and then the registry object we just call .register with our own paths. In particular, we use this for internal tools. So we have a short link system where you can have we call them Go links, where you can make a very short reference like Go candidate analysis, something like that. And you can pull that link. We'll actually follow that link through our system and go find the notebook for you. So you can just take whatever your URL is, wherever you're looking, and always share it. So the big value here we actually really see in using notebooks in the system is around failed notebooks. It's actually not the successes that are good. Success is when everything works, you don't really care. It's when something goes wrong that you actually care how you did something. Or at least that's mostly how it plays out. So we go back to that same fanning out of a bunch of parameters on a notebook. Here, if we fanned out and one of those parameterizations failed, or some users, particular input failed, traditionally in the system, you might have to go through support and say, hey, my script failed. Where's the error? Is the SD out? Maybe you have a lot of that collected already in the system, which is really good. But then, each person has to learn where those things are. One of the advantages we have here is that whenever something fails in our system for any reason, any template, any job, the user can just simply go in, click the link, see the failed job, and it actually renders in the browser very nice. This is the code you executed. Here's the stack traces. Here's the error message, all of that. And we'll show you what that looks like. It also means you can stop propagation because it acts like a normal process. So pretend we have this notebook on the right or something, where we're doing some select statement in Spark. And we want to basically just go run this thing and then see what happens. This is the original template. And we would collect logs and same types of interfaces and rerunnable code. So I could rerun whatever the user ran to. As a system maintainer, it's super useful, because if the user says, if you ask the user what did they do, and they say, I ran my thing, I ran the SQL, and you're like, okay, let me figure out how to help you. Here it's a lot easier. We can say, hey, give me a link to what you ran, and basically anyone, even people who don't work on our system, can very quickly see, oh, this is what got executed, and load it and read it. You don't need to know how the system works. You don't need how the tools work. It's pretty clear when you read something that it says Spark, and it has some SQL in it. It's probably executing SQL on Spark. So in following this kind of example, let's say we ran that and we had some sort of error. The kind of execution path you can go through there, both as self-service and as a maintainer, is you can actually go see what the issue was. You can actually get the stack trace, any details information already in the notebook. You can go try a fix by literally cloning that notebook into the UI that I first showed, tweaking it until you get the query correct or fix the configuration issue. And then you can just push that update back to the original notebook. So if many of our times, our notebooks are in source control or in a linear version control in S3. And in there, we can very quickly go play in another corner off a fork of this notebook, play with different interactions, figure out what the answer is, and then point back to the user, oh, this is what you need to change in your notebook in order to fix it. And we can do that all without interfacing or interacting with the user's actual pipeline. Right? They don't have to go and figure out how their Git repo works and how they build their assets and deploy. Everything is isolated and grouped together here. And so that's been really helpful for us in terms of supporting our users and letting our users be more self-service. So the Papermill changes to the notebook experience really is around a couple artifacts that improve and make this actually usable in production. One of the things is notebook isolation. So we've made immutable inputs, immutable outputs, where you can isolate and not touch what you ran before a second time. It also, adding the parameterization of notebook runs is really useful for being able to make these programmatic rather than human-driven systems. And then the configurable sourcing and syncing means that we can have more wider, broader impact. So there's a lot of different cloud systems that now have either contributed to make their integration better or are using heavily the integration with Papermill in order to talk to their system. And the user doesn't have to relearn the system. They can just say, hey, here's my schema, and everything works pretty well. So one thing I did want to dig into a little bit is that one of the places where you see notebooks get abused, much like any code getting abused, if you see one Python function that has 1,000 lines in it, it's probably a bad function. There's similar guidelines around notebooks. In particular, because notebooks are hard to unit test. There are some tools out there that try to achieve this, but in general, it's hard to bundle your unit test with your notebook and have it be very clear how those go together. So typically, we try not to use notebooks as libraries. They're good when you're exploring, but you still have to go through the work of productionizing your code. So where they shine is as an integration tool. They're really good about how to show how you're going to talk to 3 different systems, come to some result, and take an action. That's a really good integration where traditionally having a library is kind of awkward because it's talking between many systems. Or many times people just write a script and they never test it at all. Notebooks do give you a little bit better reliability here around when things are running what they're doing. Now what that means is you want to avoid things that are highly complex. You don't want to have many 10, 20-page long notebooks, and you want to make it fairly linear so it's easy for you to understand how it's going to run the next time. And what that means is that we keep a low branching factor where we can. We keep it short and simple is better. We try to always keep the one primary outcome, like this thing does a task, and then we link those tasks together rather than having one notebook which, say, runs 50 different jobs and then updates 50 different databases. That would be a bad use. You should use one template and use it 50 times. And then the one thing is try to leave your library functions in libraries. So oftentimes you'll develop and slowly your notebook get bigger because you'll discover, hey, I need this, and here's a little helper function and a utility here. And pretty soon, if you get a lot of that, your notebook looks pretty dense. And much like if you're writing a script and exploring how to write code, you want to productionize that and put the pieces that need unit testing in a place where you can do that. So oftentimes when we get big notebooks, we start noticing they're being larger, we start seeing errors associated with that notebook that we didn't catch in integration testing. We will actually move, we'll move those into libraries that are nearby or in some place that makes sense. Like maybe the tooling they're calling needs to have more support for different flexible options. So the reason why you want to do this and why using notebooks for integration is really good is actually using tests with Papermill is very easy. So you can, when we do this extensively at Netflix, all of our notebook templates that we provide our users have integration tests. The integration tests look a lot like a Papermill call the user would make. So we're basically going to run it just like a user would, but we give it debug or dummy inputs. Like we'll oftentimes point to tables that are canary tables that we don't care about. Or we'll point to a system on the test version of the cluster instead of the prod. And so that also means where the parameterization is kind of nice, and we have templates we want the users to use, we just usually open up parameters that allow us to point to testing or debug capabilities, and then we just run our whole suite against the test version or wherever we need the not touch prod data directly. But it means that our execution call is going to be very similar to how the user is going to use it, and we know the notebook is going to run end-to-end very smoothly. If we have the low branching factor and follow some of our other practices, it gives us pretty high to very high confidence that when a user goes to use this template, it's going to work for them. So here we have that same sort of execution that we had earlier where we were trying to do something on a region. But this time we're going to set in a region called Luna, which has a lot of users. Nobody? It's too early? All right, so we're going to figure out how many people on the moon are watching things on a particular day. And we're going to set debug to true. And what you would see in the notebook when we actually ran, you'd see this parameter cell coming in with region Luna, run date of April 2nd, and then debug equals true. We use this a lot just some things where we want to say, hey, debug is true, so we do dry run. You can also say dry run is pretty common, or maybe you want to go all the way up to a certain point, we maybe don't want to write data. Most of our tests don't do this, but a few do where the system we're talking to doesn't have a test version or is a little sensitive, then we'll do that so we don't actually touch. Generally, you want to actually touch a system, so having a test version or a dev cluster that you can point to for your test is good. And at the end of the day, we would run something like this. Maybe one of our cells is just a Spark SQL cell. And we will run insert into the output table, collect up some click events for the particular day and region match. Really simple thing, maybe we graph it afterwards. And you can let the integration test run. You can also go view the results as a human and go see like kind of what did it do. So I've talked about Papermill and kind of how we use it and how it adds to the notebook interface and how it kind of transforms the scripting concept of integration. But there's lots of other goodies in the Jupyter ecosystem, especially in the past year or two, that have been added that add a lot of flexibility and the option to go in different directions with using notebooks. We use a host of libraries, and these are just some of the ones we use at Netflix or have developed on. There's ones like mbconvert, which Papermill uses in order to do the execution. Commuter is a read-only notebook interface. NB formats like the schema that actually notebooks follow, and so on and so forth. So a whole bunch of these libraries, if you go look at the Jupyter GitHub and the nteract GitHub, you'll see a ton of projects under there that all have very neat and useful capabilities. So I'll talk about a couple more that are newer that we use or are starting to use or are developing. So Scrapbook is one. Someone said the pun game is strong. This one goes even further. This one was a fun idea that came out of talking about, well, we have notebooks as a function where you have inputs, you can templatize the input, and the output's a notebook. But that output is still something that's human readable, not program readable. So Scrapbook tries to let you solve that problem by actually registering data outcomes or visualization outcomes in your notebook. And what this lets you do is inside your notebook, you can import Scrapbook, and then you can scrapbook.glue, because you're going to glue some junk if you don't know what it is. So you're putting some nice pretty picture in your notebook. Or you're putting some data model result. And in the really basic case here, you would do something, save this in a notebook when it runs, and later you could go read that notebook back out of your source, and then ask, hey, what data results were in this notebook, and collect them by name, and then even build data frames out of collections of notebooks. This is something that was actually a functionality in early Papermill that was in a limited form, so Scrapbook is expanding that to be more broad, and so that you can grab data from more sources. And in there, this is really handy, and the original use case was around map reducing executions on like, let's say, a data science or machine learning point of view, which is why it was an early Papermill, where you want to do an alpha parameter and find out what your error value is, right? Maybe you want your confusion matrix output on a notebook, and you want to run this for 500 different experiments. And you want to collect what all the confusion matrices are to choose which parameterization worked best. This makes it really easy to just live in the same ecosystem, not have to save an output someplace else and then come back. You just save your output confusion matrix right in the notebook, and then you just recall it later. It's kind of a useful little handy tool. It's a growing thing, and would love more people to give input on interfaces here. We have a few people starting to really use it. Another thing we've used very extensively, because traditionally when we first landed in notebooks, everything was mutable, which was a scary thing when you want to share something, because what if that person changes something and they didn't intend to or you didn't want them to? So Commuter is a read-only interface for notebooks. It looks something like this, where this is one of our templates for executing Presto. You can see it's really long and high branch factor, right? It's nice and clean, so we do like trying to keep these where the tools are already built to just use the tool that exists, and mostly about adding logs and helpful information. So this would be something if you read the template that we provide users for Presto and they say, hey, when I register a Presto job, what's it actually do? We can just point them to this, they can read it and they can't edit it. Same with outcomes. All the results of their jobs, we always give them a Commuter link, which is a read-only loader of S3 or local file system mount, whatever you got mounted. And it doesn't need the whole kernel and all the other ecosystem, because at the end of the day, a notebook is actually just a JSON file that's saved someplace. So if you have something that knows what the protocol is and can read the schema, you can render that notebook anywhere, including in editors and in read-only interfaces like this. This one's really handy, so if you are adopting notebooks, I highly suggest you look into using Commuter. And just really quickly to talk about how we're using notebooks, and I've talked kind of vaguely about scheduling notebooks and things like that. We actually are very bought into using notebooks to the point where you might think we're a little crazy. In particular, when I started at Netflix about 1.5 years ago, this was the very start of kind of the heavy investment in notebook infrastructure in the data platform. And my big project that's basically coming to conclusion now is getting several different scheduled systems all to convert their data into a system that's notebook-based. And it wasn't just to change the notebooks, it was actually to upgrade our scheduler. And in the process, we saw all these users using notebooks, and we wanted to come closer to our users and try to dog food what they use and fix the problems we find, rather than complain that the technology that they like is bad. So here we've actually changed over something around 10,000 jobs, which run like 150,000 queries a day. They all run through notebooks. So we're running like millions of notebooks now, and in a templatized form. And we've seen very good results of our ability to support needs fewer people, and it's much clearer to our users what's happening. And it's much easier for our users to contribute new templates. Before, they had to know this archaic system and go write some code someplace else, and then click a button someplace, and then ask Joe to turn something on. So that nowadays it's very easy. They can say, hey, here's a notebook I ran, and this is how I want to work on it. We work with them to productionize a little bit, and then we add an integration test, and boom, anyone else can use it. So I could talk more about that maybe in the office hours if people are interested how that works, but we've had good success in using this for a particular use case, and it's grown so that now data engineers and analysts have a more natural integration with the tools they were starting to use or already using heavily. Awesome. So that's all I had.
Yeah, sure, I'll just speak up. So I had a question, how do your end users specify dependencies? You've got a couple dependencies that need to be met before a notebook runs. Do they have a way to do that, or do they work with you directly?
Yeah, so the question was around dependencies, and actually in a data sense, there's two types of dependencies. There's like library dependencies you need, and then there's data dependencies you need. Today, we plan those more at the scheduler system above. So when you're scheduling something, you're going to specify, hey, I need this data to be fresh for this time period, or for this partition, or something like that. And so you actually specify it when you're scheduling the notebook, based on how you're going to parameterize it. You as the author of the job know best. For library dependencies, that's a little bit of a harder story, which is actually starting to evolve with notebooks in particular, but it's not just isolated to notebooks. Traditionally, we lean on the systems that are already in place for dependency management, which is around we have a container that has most of the libraries we use, and then we give an easy way for users to add in new packages they need on the fly, and if they commonly use it, we ask them to get them into the image that's shared for that user group. That works pretty well to a point. There will be some scale point where that stops working, especially as we get people who write less than good libraries that conflict with each other. But we've been able to keep like maybe a half-time FTE, able to keep that running pretty smoothly for users. And that's at the scale of big data platform at Netflix, so you can go pretty far. Yeah, I would love to talk about that more afterwards. There's some good changes coming on inside notebooks being able to specify your dependencies in a better way. There are ways to do it hackily today. Yeah. I think, sure, we can go here and then there.
So how do people collaborate while working on notebooks? Like if you want to try out something, then you want to give it to somebody else where they can maybe add a few things or like add a few comments on your work and then give you a new version where you can work on it. Is that kind of a workflow that you have or support?
There is some support for that. In particular, when I showed that commuter interface, the question, by the way, if those that couldn't hear, was how do you do collaboration? Is that something you actually do with notebooks where you share and need someone to give you feedback? We actually have on our read-only interface, we have a commenting system. So there's a plugin enabled to register where you can comment kind of Google Docs style and then resolve and answer questions there. And then that's associated with your notebook object, the source of truth. So it gives the opportunity for someone to comment on a version of a notebook. And then we also use another tool called Bookstore to help version our notebooks. Yeah, someone's dying from the puns. There are tools there. Out of the box, if you started from scratch and just shared your notebook link, yeah, sharing and commenting there is not good because if two people edit the live server at the same time, bad things happen. The only system that really does that well is well, Colab used to have it, and they don't anymore. When they changed their APIs under the hood, they lost that ability, and partially because it wasn't a very common story, because it's kind of weird to edit someone's code while they're editing. There's a couple of tools that do allow you to use it. So I would look around the ecosystem. Out of the box, you won't have it. Got a question back there.
So in our pipelines and ETLs and even ML trainings, parts of the pipeline takes more CPU, more memory, and parts require GPU. Have you found a way to do this dynamically so that your notebook could take 3 hours to execute, but your one part of your pipeline requires more RAM, but the other doesn't? If you don't containerize it, if you just run it on one machine, it will just work because it's just going to use less RAM and CPU. But if you start containerizing it and running on in Kubernetes, it's allocating 100 gigs of memory for the whole entire thing. Have you found a solution to that?
There's a couple things we do. One is maybe break your problem up so you can have one template for the expensive part separate. That's pretty common. Another is sometimes if the other parts where you're holding on that memory are short, just go ahead and waste the resources because it's more effort to have a human try and fix the problem. More money to have a human fix the problem sometimes than just let it be. But when there are a few tools, and this actually is more at the orchestration side, where there's some experimentation around, because we do all container-based execution, so that's part of the isolation that we have. Our container orchestration system, which is an open source tool called Titus, is exploring with ideas around giving the minimum resources you need so you can get up to something, and if you're not using all the resources, to be able to let nearby containers take more of the resources on the box. It's still kind of an experimental thing, but generally I would say the better solution is to break up your problem so that the expensive thing uses its resources for most of the container's lifecycle.